Hey everyone. So I'm gonna go over the 6-2 homework. Some of you have 7, some of you have 6. It just kind of depends on which class of mine you're in. This is a little different than the previous homework video I already have posted. I think this is a bit more detailed. So we're just gonna head and get started. All right, so our first question here is, which of these functions are one-to-one? And so this is what we're gonna need to go ahead and do the horizontal line test, which is basically you would take a pencil or a ruler and you would go move it up and down to see if it touches more than once. So this one touches twice, so it fails. So my answer is no. If I were to draw a line here on the second one, they never touch more than once, so it passes. So it's a yes. And then here on the third graph, at the x-axis, it actually passes because that first circle is open circle, meaning I don't actually exist there, so it's not really there. So this first one is no, yes, no. And I'm gonna scroll down. Our graph 4 is going to be a no. It's really easy to see that it touches more than once for a y value. Graph 5 is a no, and graph 6 is a yes. So again, these failed because of these points here, and this graph fails in multiple places. So again, what we're looking for one-to-one is that there are no repeat y values. Ooh, which one did I miss? Your answer is for each function, say whether it's 1, 1. No, yes. I guess they do want this one to be a yes. No, no. Let's just go ahead and try. All right, so they actually are going to head and count this one as a no. So we are actually going to head and hit no on that. Sorry about that. Oh wait, no, I had clicked yes. I had clicked no. That makes no sense. So do make sure you are writing down your answer. So this one is a yes because it is an open circle. I just clicked the wrong one. All right, so for this problem, we are just going to check and see if these are inverses of each other. So So what we're going to do here is, this is saying for this first part, it's saying to plug g of x in. So I'm going to do f of g of x, which would be f of 6 over x. So everywhere I see an x in f, I'm going to put 6 over x in there. So this would be 6 over x over, oh, I'm sorry, that's wrong. So this is going to be 6 over 6 over x. And so one thing I can say, well, this is really also saying 6 over 1 over 6 over x, which I can write like this, which then tells me to go ahead and use you would keep the first one, flip the second, and you would get x when you multiply because my 6's would cancel each other out. And you should also technically get x here because it's the same thing. And in theory, I should get, they are inverses because it equals x. For part B, we're going to do f of 2x plus 1. So that would be 2 times 2x plus 1, which is 4x plus 2. And then for g, I'm going to do 2x. Oh, and then I forgot the minus 1. So minus 1, so this is 4x plus 1. So then we're going to do g of 2x minus 1. So I'm going to get 2 times 2x minus 1 plus 1, which gets me 4x minus 2 plus 1, which equals 4x minus 1. So this is going to be 4x plus 1, and this is going to be 4x minus 1. And since part A both equals x, they are inverses of each other. And since part B, they do not equal x, they are not inverses of each other. One of the things I would suggest on this specific problem is to take a look at the example where they are going to explain that. And it'll tell you if you get x on both of them, then they are. So moving on to the next problem. All right, so for the one-to-one functions, G and H are defined below. Find the following. So for part 1, we're going to go ahead. What you're looking for is going to be, you're going to find the y value that has this here in the set, because this is going to be my list of coordinate points. So you're going to look for the one that has the y value of -8, and that x value is going to be your answer. So in this case, it's going to be -3. My other hint here is going to this last one. If they are truly inverses of each other, your input is also going to be your output. So I'm just going to put 5 there. This line here is to make sure you actually did the inverse setup correctly for this middle part. So my first step is to write it as y equals, so 2x plus 9. And then I'm going to go ahead and switch my x and y. And then I'm going to solve for y. So I'm going to subtract 9. And then now we're going to divide everything by 2. So we get x minus 9 all over 2 equals y, which I could rewrite this y instead in function notation. And in this case, it's going to be h to the -1 of x. So x minus 9 over 2. Go ahead and leave it as that fraction. Don't try to mess with it. So x minus 9 all over 2. You don't need to simplify the fraction, just leave it as is. Did you freeze? I think my Alex froze on my end here because it is a light shade. It's not doing anything. Let's hit refresh and see if it keeps me logged in. All right, we're just going to jump to question 4. All right, there we go. All right, considering the function the square root of 3x minus 9 for the domain of x to infinity or 3 to infinity, and also state the restricted domain. So what we're going to do here is, one of the things you have to remember, a square root is canceled out by a squared. And this is later on, a cube root is canceled out by a cube. And then if you want to keep going, a fourth root is canceled out by a power of 4. So we don't really see it here, but there is a little invisible 2 there. And pretty much you just raise to that power to cancel it out. So we're going to head and start with writing our inverse function. So I'm going to write y equals the square root of 3x minus 9. I'm going to switch x and y. And I'm going to solve for y. So my first step is actually to square both sides. When we do that, the radical and the exponent cancel out over here. So we have x squared equals 3y minus 9. I'm then going to add 9 to both sides. And then we're going to divide everything by 3. Again, I'm going to leave this as a fraction because it does let me, right here, it lets me use a fraction. So I'm going to leave it as a fraction of 3x squared plus 9 over 3. I'm going to leave it like that. I'm not going to change it. We're just going to leave it like that. The other thing here is in class, we went over that domain and range flip locations for inverses. So if this is my domain of my original, it becomes the range. And so that's the same thing going to the other end, that I'm going to take the domain, the range of this, which would be 0 to infinity. This becomes my range. I'm sorry, it becomes my domain. So I'm gonna, we said it was x squared plus 9 over 3. So I'm gonna write a fraction. I'm gonna do x squared plus 9 all over 3. And then I'm going to look for a bracket parenthesis, which is here. And we're going to go from 0. And I'm going to get. And I want infinity. I would only simplify this fraction if they said to simplify the fraction. If they don't tell you to simplify it, I'd leave it as it is. Don't take the chance of making a mistake after you've already worked it out. All right, so this time we have a cubic. Our steps are the same. The only difference here is I don't have to worry about a restricted domain because of the shape of the graphs. So we're going to start off with y equals x cubed minus 4, switch x and y. So next, I'm going to start off by adding 4 because my goal is to get y by itself. So we get x plus 4 equals y cubed. I then take the cube root of both sides, and that will cancel out the roots and the exponent on that side. And I'm left with the cubic root of x plus 4 equals y, or in this case, f to the negative 1. So we're going to go with this one here. We're going to put a 3, so I know I'm talking about 3. And I have x plus 4. All right, next we want to go ahead and graph the inverse of a function or of a graph shown. What we're going to do here is we're actually going to take a look at our endpoints. So I'm looking at here, here, and here. So those are the coordinate points, -7, -5, -0, -4, and lastly, 3, -2. So in class, we talked about how you would just switch your x and y values to find the inverse. So this would become -5, -7. This would become -4, 0. And this would become -2, 3. So when we're doing this, we have a couple options of how we type it in. You can just do the point if you feel really comfortable doing this one. So like, for example, I know -40 was one, -5, -7. And then our last one is -2, 3. That doesn't sound right. Oh, that makes more sense. So -5, -7. 1, 2, 3, 4, 5, and it's down. And then -40, that was not an issue. -2, 3. All right. Next, what I'm going to head and do is we're going to draw our line segments. And I'm going to draw another one. And then I'm going to hit check. So I am going to make sure I -7, 1, 2, 3, 4, 5. So what I would do in this case, that's not what I want. All right, so we wanted, making sure I get these right, -5, -7. I'm gonna plot that point. Hopefully it's there. I don't know if it is. All right. -5, -7. So we're gonna plot -5, -7, and hit plot. All right, and next I'm gonna do -0, -4. So -4, 0. And this is at 3, -2, so it should be -2, 3. Right, so we're gonna draw my lines. What's the same? I don't know what the difference on the previous one was. I do suggest using the point thing to make sure you have it right. Because I just plotted the points we said. So I'm not quite sure. I could have counted wrong when I was trying to do it by hand. So it is always also a good idea to use that plot. All right, and let's go to question 7. This was the extra question that certain classes had, but not everybody. And it was put at the end solely because I do know not everybody was going to do it. All right, so a tank is being filled with a liquid LFT. Given below is the amount of liquid in liters in the tank after t minutes. LFT equals 2.5 t plus 11.5. Complete the following statements. So we're actually going to describe what the inverse is going on. So for my original L of T, I want to know what my input is and what my output is. So T is time. That is my input. My output is the amount of liquid. So I'm just gonna put amount of liquid. So when we look at our inverse, L to negative 1 of X, let me see, they're actually gonna switch. And so that my input is now liquid and my output is now time. So I'm going to take a look at my answer choices here for what describes my inverse. So again, if I'm starting at my original saying I'm putting in time, I'm getting out liquid, my inverse should say I'm putting in liquid and getting out time. So it is going to be, my output is how long it will take to have X liters of liquid. So I'm going to go with, that's actually the one I'm going to go with. The reciprocal and the ratio, that makes no sense in this case, because the inverse is going to be undoing something. The amount of liquid after X minutes. So these should be opposite of each other, between the two that you're checking. All right, and then they actually want you to solve for your inverse. Linear equations are pretty easy. Y equals 2.5 X plus 11.5. We switch X and Y. And then we're going to solve for X, or solve for Y, I'm sorry. So we're going to subtract 11.5 from both sides. And now we're going to divide everything by 2.5. Okay, they do give me a calculator, that's great. So we're going to get X minus 11.5 over 2.5. And then for part C, I'm just going to plug 90 into my equation and see what I get. And I'm just going to use actually the calculator that they gave us. So I'm going to go ahead. We're going to say this. My answer here was again X, so a fraction. We're going to say X minus 11.5. All over 2.5. Yes. All right, and so then I'm going to take the calculator that they provide, or you can use the Desmos calculator, whichever you want. So I'm going to do 90 minus 11.5 is equal. I get 78.5, and I'm going to divide that by 2. And I get 39.25. 39.25. I'm going to hit check. Does it tell me which one I'm wrong? Part C is wrong. Let me double. Oh, I divided by 2, didn't I? Not 2.5. So 90 minus 11.5. Divide that by 2.5. 31.4. Again, I keep all my mistakes in here so that you can see it does happen. Can have everything right, and then if you don't press the right numbers, don't do the right thing, it doesn't work. And I don't know why I just refreshed that. I think it's going to change the question. And it probably did, but that is 6-2. So hopefully this does help out. Hopefully you were in class, but if not, I do hope this actually helps you on your homework, and best of luck.